Hello, curious minds. Did you know there are mysterious objects in space that are too big to be planets and too small to be stars? They're one of the universe's strangest secrets. Are they failed stars or something entirely different? Let's dive in and find out. Out there in the vast expanse of space exists a class of celestial objects that have long fascinated astronomers, brown dwarfs. These objects sit in a unique position in the cosmic hierarchy, bridging the gap between the largest planets and the smallest stars. Brown dwarfs typically have masses between 13 and 80 times that of Jupiter. This mass range is crucial because it determines their ability to fuse deuterium. We'll talk about this later. Another fascinating aspect of brown dwarfs is their magnetic activity. Despite their relatively low temperatures, some brown dwarfs exhibit strong magnetic fields and even auroras, similar to those seen on planets like Jupiter. So, in a nutshell, that's the realm of brown dwarfs. They are too massive to be considered planets, yet not massive enough to sustain the hydrogen fusion that defines true stars. To truly understand brown dwarfs, we need to delve deeper into the cosmic kitchen where these fascinating objects are born. Brown dwarfs are often referred to as failed stars, but this term doesn't do justice to their unique characteristics and the role they play in the universe. These objects arise from the collapse of massive clouds of gas and dust, much like stars do. However, their journey diverges due to their mass. Primarily composed of hydrogen and helium, these clouds undergo a process that determines their ultimate fate. The fate of a collapsing cloud depends on its mass. If the cloud has sufficient mass, it will continue to collapse under its own gravity, eventually igniting nuclear fusion in its core. This process leads to the birth of a star, a luminous object that shines brightly in the night sky. However, if the cloud lacks the necessary mass, it cannot sustain the nuclear fusion process. Instead, it forms a brown dwarf, an object that occupies the gray area between stars and planets. The core of a brown dwarf never gets hot enough to sustain hydrogen fusion like a star. This means that while they may start off relatively warm, they do not have a continuous source of energy to keep them shining. Instead, brown dwarfs undergo gravitational contraction, a process where they slowly shrink and release heat. This heat is emitted as a faint infrared glow, making them detectable with infrared telescopes. Over time, brown dwarfs cool down, and their atmospheres undergo significant changes. These atmospheres are primarily made of hydrogen and helium, but they also contain trace amounts of chemicals like methane, water vapor, and even ammonia. These chemicals absorb and emit light in specific ways, leaving unique spectral fingerprints that astronomers can analyze. By studying these fingerprints, scientists can determine the temperature, composition, and even weather patterns on these strange worlds. Some brown dwarfs even show signs of cloud formations, made of exotic materials like silicates or iron droplets, creating storm systems that stretch across their entire surface. As they age, they become cooler and dimmer, making them harder to detect. By understanding these objects, we can learn more about the diversity of celestial bodies in our universe and the complex mechanisms that govern their formation and evolution. So, where do these enigmatic brown dwarfs reside? Brown dwarfs have been found throughout our galaxy, often in star-forming regions. Unlike stars, brown dwarfs are more likely to be found on their own, solitary wanderers. Interestingly, some brown dwarfs have been found to host their own planetary systems, much like stars. They're also found in binary systems, often paired with stars or other brown dwarfs. Astronomers have also discovered brown dwarfs orbiting other stars at great distances. Finding brown dwarfs is challenging due to their faintness, requiring specialized infrared telescopes. Why infrared, you ask? As brown dwarfs cool, they release energy in the form of infrared radiation, a type of light our eyes can't see but specialized telescopes can detect. Infrared light can penetrate through cosmic dust clouds that often obscure visible light, making it an invaluable tool for locating these elusive objects. Despite these challenges, thousands of brown dwarfs have been discovered, expanding our understanding of the galaxy. As our observational capabilities improve, we can expect to uncover even more brown dwarfs. Let's compare brown dwarfs to their cousins, planets, and stars. These three types of celestial objects, while sharing some similarities, have distinct characteristics that set them apart in the vast expanse of the universe. Planets like Earth orbit stars and do not generate their own light. They are composed of various materials, including rock, metal, and gas, and their atmospheres can vary widely. Some planets besides Earth are thought to have conditions that can support life, while others are barren and inhospitable. Stars are massive balls of hot gas, generating energy through nuclear fusion. This process occurs in their cores, where hydrogen atoms fuse to form helium, releasing tremendous amounts of energy in the form of light and heat. Stars come in various sizes and colors, from small red dwarfs to massive blue giants. Brown dwarfs occupy a middle ground, more massive than planets but less massive than stars. They are often referred to as failed stars, because they do not have enough mass to sustain the nuclear fusion of hydrogen in their cores, which is the defining characteristic of a true star. But they can fuse deuterium, which is a heavier type or hydrogen. Unlike regular hydrogen, which has just one proton in its nucleus, deuterium also has a neutron. This tiny difference makes it easier to fuse under lower temperatures and pressures, perfect for brown dwarfs. Deuterium undergoes fusion with another proton. This fusion primarily produces helium-3 and releases energy in the process. This occurs at lower temperatures and pressures than hydrogen fusion, allowing brown dwarfs to shine faintly, especially when they are young. Over time they cool and fade, becoming more difficult to detect. Planets are typically less than 13 times the mass of Jupiter. This mass limit is significant because it marks the boundary where deuterium fusion can occur. Below this threshold, objects are considered planets, and they do not have the conditions necessary for any type of fusion. Brown dwarfs range from about 13 to 80 times the mass of Jupiter. This range allows them to fuse deuterium but not hydrogen. Stars have a minimum mass of about 80 times the mass of Jupiter. This mass is necessary to achieve the core temperatures and pressures required for hydrogen fusion. Stars can grow to be much larger, with the most massive stars being hundreds of times the mass of the Sun. Brown dwarfs share a hydrogen-helium composition but can have higher abundances of heavier elements. These elements, such as lithium and carbon, can provide clues about the formation and history of brown dwarfs, as well as their differences from both planets and stars. By understanding the differences and similarities between planets, brown dwarfs, and stars, astronomers can piece together the complex puzzle of our universe's history and the processes that govern it. Now the big question: could brown dwarfs harbor life? Brown dwarfs emit much fainter radiation than stars, primarily in the infrared spectrum. The habitable zone around a brown dwarf would be much smaller and closer than around a star like our Sun. Planets in this zone would be tidally locked, with one side always facing the brown dwarf. Despite these challenges, the possibility of life around brown dwarfs cannot be entirely ruled out. Brown dwarfs emit significant heat, especially in their youth, potentially supporting liquid water. Tidal heating could generate internal heat within orbiting planets. Life is incredibly adaptable, thriving in some of the most extreme environments on Earth. So, who knows what might be possible out there in the universe? The search for life around brown dwarfs represents an exciting frontier in astrobiology. And there you have it. Brown dwarfs, neither stars nor planets, but something entirely unique. Do you think we'll ever find a planet orbiting a brown dwarf that could support life? Drop your thoughts in the comments below. If you enjoyed this adventure, hit that like button, subscribe for more cosmic discoveries, and ring the notification bell. Thanks for watching. Until next time, keep looking up.